morning, everyone. So let us start our new chapter, three-dimensional geometry. Can you hear me? Okay. So let us start from the concept of direction cosines, which we had learned in vector algebra. There, if we consider xy plane, and a line OP, a vector OP, which makes an angle alpha with the positive direction of x-axis, then the direction cosines L is equal to cos alpha, if alpha is the angle made by the vector OP with the positive direction of x-axis, then L is equal to cos alpha. See, this is what we had learned in vector algebra, that is L is equal to cos alpha. This is the direction cosine. And when we are considering a line in a space in three-dimensional geometry, this is the difference here. We are not considering a vector here, we are considering a line in a three-dimensional space. So it extends to both the directions. So if this angle is alpha here, it makes an angle pi minus alpha with the positive direction of x-axis also. Okay, so see the total angle here is 180 since it is a line, and if this angle is alpha, this angle becomes pi minus alpha. Okay, so this L is equal to cos alpha. The same L can be written as cos of pi minus alpha. Which is equal to, this is equal to minus cos alpha. Okay, so L the direction cosines, therefore the direction cosines are plus or minus L. Similarly, plus or minus M and it is plus or minus N. Okay, the direction cosines are plus or minus L, plus or minus M and plus or minus N. This is the difference in direction cosines which we had learned in vector algebra, and the direction cosines now we have to learn. See, in vector algebra we had learned to write the direction cosines of a vector. Vector means only one direction here, but here we are considering a line in a space. So when you are considering a line, it makes an angle alpha with the positive direction of x-axis. At the same time, here the remaining angle is pi minus alpha, that also makes with the positive direction of x-axis. So two different angles will be there, that is cos alpha and cos pi minus alpha. Cos alpha is taken as L, whereas cos pi minus alpha is minus cos alpha, which is equal to minus L. So plus or minus L, plus or minus M or plus or minus N are the direction cosines of a line. Is it clear? Is this clear? I will explain it once again. See, when we consider an xy plane, a vector OP we are considering here, a vector OP. If this angle is alpha here, then the direction cosine is of the vector is L is equal to cos alpha. At the same time, it makes an angle beta with the y-axis. Beta with the y-axis, then M is equal to cos beta, and with the z-axis it makes an angle gamma, then N is equal to cos gamma. Okay, at the same time, if we are considering a line in a space, this extends to both the directions. That is, this vector OP becomes a line here. Let this line be L. So to write the direction cosines of this line L, we can consider this angle, or we can consider the remaining angle here. The total angle here is 180 degree, that is pi radians. So here if this angle is alpha, this becomes pi minus alpha. So either you can consider this as the direction angle, or you can consider this as the direction angle. So in this case we are saying the direction cosines are L is equal to cos alpha. At the same time, we can write this as cos of pi minus alpha. Cos of pi minus alpha is minus cos alpha. That means it is minus L. So there are two direction cosines here, plus or minus L. Similarly, plus or minus M and plus or minus N. So the direction cosines of a line, direction cosines of a line in a space are given by plus or minus L, plus or minus M, plus or minus N. Is it clear now? Is the video clear now? Okay. Okay. So for a line, there are two sets of direction cosines. One is plus L minus plus M and plus N. Other one is minus L minus M and minus N. And now the next is any three numbers A, B and C. Any three numbers A, B and C which are proportional to L, M and N are called the direction ratios. Of the line. The same definition we had learnt in vector algebra also. Any three numbers which are proportional to this L, M and N, that is A, B and C are proportional to L, M and N, which are called the direction ratios of the line. So can you say how many direction ratios will be there for the line? Direction ratios means numbers which are proportional to the direction cosines. So can you say how many direction ratios are there for a line? See, let us consider the direction cosines of a line as 0, minus 1 by root 2, 1 by root 2. Okay, so we are considering the direction cosines. I will write one direction ratio here. It is 0, minus 2 by root 2, 2 by root 2. This is one direction ratio of the line. We can write another one. This is proportional to the direction cosine here. I can write another one here, minus 3 by root 2, then 3 by root 2. This also is proportional to the direction cosine here. Like this, how many direction ratios will be there for a line? These are numbers which are proportional to the direction cosines. Like this, how many direction ratios you can write for a line? Give your answer. Yes, infinitely many direction ratios are there for a line. So you can write that there are infinitely many direction ratios for a line. There are infinitely many direction ratios for a line. But direction cosines are unique. See, as we are considering the direction here, either this will be plus L plus M or plus N, or it is minus L minus M minus N. So the direction cosines are unique, whereas the direction ratios are infinite. Is it clear? Okay, so let us move to the next one. Relation between this direction ratios and direction cosines. That also you had learnt in vector algebra. We know that L square plus M square plus N square is equal to, what about this relation? L square plus M square plus N square. If L, M and N are the direction cosines of the line, then L square plus M square plus N square is equal to, what about this sum? This also you had learnt in vector algebra. It is equal to 1. Okay, L square plus M square plus N square equal to 1. All of you be regular in your studies, otherwise this chapter will be very difficult for you. Okay, if you don't know these basic concepts, then it will be very difficult. See, L square plus M square plus N square is equal to 1, and you know that L is equal to, since we are considering a line in a space, we can write this as plus or minus A divided by root of A square plus B square plus C square. This is the modulus of, we are considering this as the modulus. So it is equal to the magnitude. So this equals root of A square plus B square plus C square. M is equal to plus or minus B divided by root of A square plus B square plus C square, and N is equal to plus or minus C divided by root of A square plus B square plus C square. This is the relation between the direction ratios and the direction cosines. A, B and C are the direction ratios. To find the direction cosines from it, we have to find plus or minus A divided by root of A square plus B square plus C square. M is equal to plus or minus B divided by root of A square plus B square plus C square, and N is equal to plus or minus C divided by root of A square plus B square plus C square. Okay. Now the next heading is direction cosines of a line passing through two given points. Passing through two given points P x1 y1 z1 and q x2 y2 z2. So the direction cosines of a line which passes through two given points P x1 y1 z1 q x2 y2 z2 is See, we can write this direction ratio as x2 minus x1 divided by, this is modulus of this PQ, so we can write it as PQ. x2 minus x1 divided by PQ. Then M equals y2 minus y1 divided by PQ. y2 minus y1 divided by PQ means magnitude of PQ. And N is equal to Z2 minus Z1 by PQ. PQ means it is the distance between the 2 points P and Q, which can be written as root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So L is equal to x2 minus x1 divided by PQ, M is equal to y2 minus y1 divided by PQ, and N is equal to z2 minus z1 divided by PQ, where PQ equals root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. These are the direction cosines. So the direction ratios are x2 minus x1, y2 minus y1 and z2 minus z1. Is it clear? So I will repeat this once again. If the direction angles are alpha, beta and gamma, then the direction cosines given by cos alpha, cos beta and cos gamma. At the same time, we can write the direction angles are as pi minus alpha, pi minus beta and pi minus gamma, which gives the direction cosines as minus cos alpha, minus cos beta and minus cos gamma. These two together, we write this as plus or minus L, plus or minus M and plus or minus N. Okay. The numbers A, B and C, which are proportional to L, M and N respectively, are called the direction ratios. And from here we can write this as L square plus M square plus N square is equal to 1. That is the sum of squares of the direction cosines equal to 1. And also we can write this L as plus or minus A by root of A square plus B square plus C square. M is equal to plus or minus B by root of A square plus B square plus C square, and N is equal to plus or minus C by root of A square plus B square plus C square. See here, A, B and C are the direction ratios. L, M and N are the direction cosines. These three are the direction cosines. And here A, B and C are the direction ratios. Always remember this. And when 2 points P x1, y1, z1 and q x2, y2, z2 are given, then we can write this as L is equal to A is x2 minus x1, and here this root of a square plus b square plus c square is the distance between the 2 points, which is to be written as PQ. And m is equal to, see here, b by root of, that is y2 minus y1. y2 minus y1 divided by root of a square plus b square plus c square. And n is equal to z2 minus z1 is c. z2 minus z1 by, here root of a square plus b square plus c square is the distance between p and q, which we written as PQ. So you have to remember these relations. x2 minus x1, y2 minus y1 and z2 minus z1 are the direction ratios of the line PQ, and the direction ratios divided by the magnitude of PQ gives the direction cosines. I hope this is clear to you. Okay, let us do some questions from exercise 11.1. First one, if a line makes an angle, makes angles 90 degree, 135 degree and 45 degree with x, y and z axis respectively, x, y and z axis find its direction cosines. Find its direction cosines. If a line makes angles 90 degree, 135 degree and 45 degree with x, y and z axis respectively, find its direction cosines. So the direction cosines, L is equal to cos 90, M is equal to cos 135 and N is equal to cos 45. Write the values. What about cos 90? What's the value of cos 90? It is 0. Okay, then cos 135. This 135 can be written as pi minus 45. This can be written as pi minus or 180 minus 45. Which is equal to minus cos 45, and the value is minus 1 by root 2. and n is equal to cos 45, which is equal to 1 by root 2. Therefore, 0 minus 1 by root 2 and 1 by root 2 are the direction cosines. Cos 135 is can be written as 180 minus 45, or you can write this as 90 plus 45. Whatever it be, you will get the value of this as m is equal to minus 1 by root 2, then n is equal to 1 by root 2. So 0, minus 1 by root 2 and 1 by root 2 are the direction cosines. Okay, now the second one. Find the direction cosines of a line Find the direction cosines of a line which makes equal angles with the coordinate axis. Find the direction cosines of a line which makes equal angles with the coordinate axis. That is, alpha is equal to beta is equal to gamma. Alpha, beta and gamma are the angles made with x-axis, y-axis and z-axis respectively. Then alpha is equal to beta is equal to gamma. It is given here that it makes equal angles with the coordinate axis. So cos alpha will be equal to cos beta, which is equal to cos gamma. Cos alpha is L, which is equal to M, is equal to N. And also we know that L square plus M square plus N square is equal to 1. Since L is equal to M is equal to N, we can write this as L square plus L square plus L square, which is 3L square is equal to 1. L square is equal to 1 by 3, or L is equal to plus or minus root of 1 by 3. Or this can be written as plus or minus 1 by root 3. Therefore, the direction cosines are plus or minus 1 by root 3, plus or minus 1 by root 3, plus or minus 1 by root 3. All L, M and N are equal. Is it clear? Okay, now let us move to the next one. If a line has the direction ratios, minus 18, 12 and minus 4, then what are its direction cosines? What are its direction cosines? So we have to use the relation a by root of a square plus b square plus c square, b by, this is to be taken as A, B and C, the direction ratios. If a line has the direction ratios, so these are the direction ratios here. A, B and C are the direction ratios. To find the corresponding direction cosines, we have to use plus or minus A by root of A square plus B square plus C square. Dear children, please wait for 1 minute. Can you hear me? Okay. So here in this root of So this root of 18 square plus 12 square plus 4 square, which is equal to root of 18 square is 324 plus 144 plus 16. This is equal to root of 484, which is equal to 22. It is 484, which is equal to 22. And so the direction cosines are a by root of a square plus b square, which is minus 18 by 22, 12 by 22, and minus 4 by 22. That is, we can write this as minus 9 by 11, 6 by 11, and minus 2 by 11. Is it clear now? Okay, so let us move to the next one. Please wait for a minute. Okay, now let us move to the next question. Show that the points show that the points 2, 3, 4, minus 1, minus 2, 1, and 5, 8, 7 are collinear. Show that the points 2, 3, 4, minus 1, minus 2, 1, and 5, 8, 7 are collinear. See, here we are going to write the direction ratios of AB. Let A be the point 2, 3, 4, then B minus 1, minus 2, 1, and C 5, 8, 7. Let us write the direction ratios of AB. Direction ratios of AB are, how can you find the direction ratios of the line joining A and B? What are the direction ratios of AB? We can find it using x2 minus x1, y2 minus y1, z2 minus z1. So it is minus 1 minus 2, which is minus 3, then minus 2 minus 3, which is minus 5, 1 minus 4, which is equal to minus 3. The direction ratios are x2 minus x1, y2 minus y1, z2 minus z1. Similar way you can find the direction ratios of BC. Find out the direction ratios of BC. And give your answer. It is 6, 10, 6. Okay, now see, when you find the direction ratios of A, B and BC, you have to check whether these direction ratios are proportional. Are they proportional? Are they proportional here? Yes. So direction ratios of AB and BC are proportional. See, minus 3 into minus 2 it is 6, minus 5 into minus 2 it is 10, minus 3 into minus 2. Multiplying with minus 2 here, or this is a scalar multiple of the direction ratios of AB. That means, what you can write from this? The direction ratios of AB and direction ratios of BC are proportional, or the direction ratios of BC are the scalar multiple of direction ratios of AB. So what you can write about these two lines AB and BC? In vector algebra you had learned this. If you consider this AB as a vector, then you can write this as minus 3i minus 5j minus 3k. BC as a vector 6i plus 10j plus 6k. So this is a scalar multiple of vector AB. So what can you say about this AB and BC? Scalar multiple of a vector. So I have to give you the answer. AB is parallel to BC. Parallel vectors or collinear vectors. You had learned this in vector algebra. Okay. So direction ratios of AB and BC are proportional, which implies AB is parallel to BC, and also B is a common point. B is a common point. So A, B and C are collinear. This is another method of proving collinearity of 3 points. We had already learned how to prove 3 points are collinear in vector algebra. There we are finding vector AB, vector BC and vector AC. Then their modulus, and then AB plus BC gives is equal to AC. If it satisfies that condition, then also we can say that the points are collinear. This is another method. Direction ratios of AB and direction ratios of BC you have to find. If they are proportional, the two lines are parallel, and B is a common point. Therefore, A, B and C are collinear. Is it clear? Okay, now another one. Find the direction cosines of the sides of a triangle Find the direction cosines of the sides of a triangle whose vertices are A 3, 5, minus 4, B minus 1, 1, 2 and C minus 5, minus 5, minus 2. Find the direction cosines of the sides of a triangle whose vertices are A, B and C given here. So you can write the direction ratios AB, BC and AC. The direction ratios of AB minus 4, then minus 4, 6, minus 1, minus 3, it is minus 4, 1 minus 5, it is minus 4, 2 minus minus 4, it is 6. Similarly, the direction ratios of BC minus 5 minus minus 1 which is minus 4, minus 5 minus 1 it is minus 6, minus 2 minus 2 it is minus 4. Then the direction ratios of AC minus 8, minus 10, then 2. Okay, minus 5, minus 3, minus 5, minus 5, then minus 2 plus 4. These are the direction ratios of AB, BC and AC. So the direction cosines are direction cosines of AB minus 4 divided by root of A square plus B square plus C square. Find the answer. Root 68, okay. Minus 4 divided by root 68, or you can write it as 2 root 17. Okay, minus 4 root 4 by 2 root 17, then 6 by 2 root 17. Similarly, you can find the direction cosines of BC and AC. Here also the same numbers, so it is minus 4 by will get us 2 root 17, then minus 6 by 2 root 17, then this is minus 4 by 2 root 17. Here it is minus 8 by root 168, minus 10 by root 168, and 2 by root 168. So these are the direction cosines of the three sides AB, BC and AC. Okay, now the next topic is equation of a line in a space. Equation of a line in a space. So in this, there are two different forms or two different types of equations. One is vector equation and the other one is Cartesian equation. So two different types of equations for every line. One is a vector form of equation and the second one is a Cartesian form of equation. That means in vectors, we can write a vector as vector A, or if the component form is given here, that is vector A can be written as xi plus yj plus zk. So two different forms here. This is the vector form and this is the component form. Similarly, for a line, there are two different types of equations. One is vector equation and the second one is Cartesian equation. So let us consider the first one. First case, equation of a line. Equation of a line passing through a given point. Passing through a given point and parallel to a given vector. Parallel to a given vector. So here the conditions given, you have to write the equation of a line. Equation of a line in a space which passing through a given point. So let us consider here a line L which passes through a point, say A, and the coordinates of the point B, x1, y1, z1. This is given to us. A point, we have to write the equation of this line L which passes through the point A, x1, y1, z1, and this line is parallel to a vector B. So these two will be given to us. That is a point A, x1, y1, z1 and a vector B which is parallel to the line will be given to us. We have to write the equation of this line L. So let us consider this point A. Its position vector is the vector joining A to origin. This is the position vector of the point A. Let us consider this as vector A. So vector A can be written as x1i plus y1j plus z1k. And let us consider any point on this line L, let that be equal to P. We are considering an arbitrary point P, X, Y, Z. And let its position vector be R. So vector R is equal to xi plus yj plus zk. Since this B is parallel to this AP, see L is parallel to B. It is given to us. So since this is parallel, they are collinear vectors. That means this is a scalar multiple of vector B. We can write this as lambda B. AP is equal to, vector AP is equal to lambda vector B. Collinear vectors means scalar multiples. So since this is B, we write this as lambda vector B. And this B in component form, let us write this as AI plus BJ plus CK. This is the component form of vector B. B is taken as AI plus BJ plus CK. See, these notations you have to remember. Then only we can write the equation of a line or equation of a plane to find the angle between two lines, whatever it be. These notations have to be clear to you. See, now a point given to us is to be taken as x1, y1, z1. So its position vector is x1i plus y1j plus z1k. Then a general point is considered here, which is P, and it is taken as xyz as the coordinates. So the position vector is taken as R. Whenever we consider a general point or an arbitrary point, its position vector is to be considered as R. This is equal to xi plus yj plus zk. And here a vector which is parallel to the given line, which is to be taken as AI plus BJ plus CK. Is this clear? Okay, now, so here we can apply triangle law of addition. See, O, A, P, 3 points are here and 3 vectors are here. We can apply the triangle law of addition. OA plus AP gives OP. So, OA plus AP is equal to OP. OA, its terminal point is A. From there, AP is the vector. Then by adding these two, the resultant vector is OP. OA is vector A plus AP is lambda vector B. This is equal to vector R. This is the vector form of a line. Vector equation of a line. Vector equation of a line is R is equal to A plus lambda B, where A is the position vector of the point given to us. B is the vector which is parallel to the line. And when we write this in using component form of these vectors, we can write vector r. That is, vector r in component form can be written as xi plus yj plus zk. This is equal to, see, this is r equals xi plus yj plus zk. This is equal to vector a can be written as x1i plus y1j plus z1k plus lambda into ai plus bj plus ck. Okay, we are applying the component form of these vectors a, b and r here. R is xi plus yj plus zk. Vector a is x1i plus y1j plus z1k plus lambda is into b is ai plus bj plus ck. And equating the corresponding components here, we can write this x is equal to x1 plus a lambda, x1 equating the components of I, scalar components of I, here x1 plus lambda a, which is equal to x, y is equal to y1 plus lambda b, and z equals z1 plus lambda c. From this, find the value of lambda in each case. From each of these equations, find the value of lambda. What you will get? From the first one, lambda is equal to x minus x1 by a. From the second one, lambda equals y minus y1 by b. From the third one, lambda is equal to z minus z1 by c. Isn't it? So here in all these cases lambda is the same. So here we can write this as x minus x1 by a is equal to lambda, which is equal to y minus y1 by b, which is equal to z minus z1 by c. This is the Cartesian form of the equation of a line. Cartesian form of equation of a line. So we had learned two different types of equations. Vector equation is r is equal to a plus lambda b, and the Cartesian equation is x minus x1 by a equals y minus y1 by b equals z minus z1 by c. Here always you remember, we are writing the equation of a line which passes through the point x1, y1 and z1 and is parallel to a vector whose direction ratios are a, b and c respectively. Okay, you have to remember this. The denominator of this gives the direction ratios of a vector which is parallel to the given line. Parallel to the line, and x1, y1, z1 are the coordinates of the point through which the line passes. Is it clear? Okay, with one question here. Find the equation of the line in vector and in Cartesian form which passes through the point 1, 2, 3 and parallel to the vector 3i plus 2j minus 2k form which passes through the point 1, 2, 3 and parallel to the vector 3i plus 2j minus 2k. See, always remember this one. This is to be taken as vector A. Okay, vector A can be written as I plus 2j plus 3k, the point given to us. This is to be taken as vector A, or you can write here or x1, y1, z1 is equal to 1, 2, 3. And now vector B is parallel to the line, that is to be taken as 3i plus 2j minus 2k, or you have to write this as A, B, C. These are the direction ratios are equal to 3, 2, minus 2. See, this part we can use for writing the vector equation, and this you can use for writing the Cartesian equation. Okay, now vector A and vector B, this form we can use to write the vector equation, and here this can be used to write the Cartesian equation. Let us write now vector equation. Vector equation is R is equal to A plus lambda B. This is the vector equation. Here you have to apply these values of vector A and vector B. Vector A is I plus 2j plus 3k plus lambda into B is 3i plus 2j minus 2k. 3i plus 2j minus 2k. No need to simplify. This is the vector equation. Okay, now the next is Cartesian equation. Cartesian equation is, we can use the second part of this, that is x1, y1, z1 is 1, 2, 3. So the Cartesian equation of a line is x minus x1 by a equals y minus y1 by b equals z minus z1 by c. So here x minus x1 is 1 by a is 3, which is equal to y minus y1 is 2. See, x1, y1, z1. So it is x minus 1 by, this is a, b and c. So it is by 3 equals y minus 2 by b is 2. This is equal to z minus z1 here is 3 divided by C is minus 2. So this is the Cartesian equation. Is it clear? Okay, try to learn this today itself. We will do the remaining problems in the next class. And it will be easy for you only when you can identify this x1, y1, z1 and a, b, c from the question. So learn it today itself. We will do it tomorrow. Do the remaining questions of exercise 11.2. Okay, thank you.